Hi everyone. So after learning about the rules of divisibility, let us now look at the concept of HCF and LCM and how to solve the questions based out of it. So HCF is nothing but the highest common factor. So and LCM is the least common multiple. So given that we are having two or more numbers, so the factor which is common in all those numbers is called a common factor. And the highest among those common ones is called the highest common factor. And it is also called as greatest common divisor. For example, we have a number 4 and 26. Okay. Now the factors of 4 are 1, 2, 4. And the factors of 26 are 1, 2, 13, and 26. Now, 1 is a common factor and 2 is a common factor in these two numbers. But which one is higher? 2. So, HCF is equal to 2. And HCF is written as HCF of 4, 26 is equal to 2. Okay. So this is about the highest common factor or the greatest common divisor. And the second one is least common multiple. So least common multiple means, let us consider this example only. So the multiples of 4 are 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, and so on. And the multiples of 26 are 26, 52, 78, 26 4 is a 104, and so on. Now see, the multiples of 4 will be 44, 48, 52, and so on. So 52 is a common multiple, right? And it is the lowest among all the common multiples that will be there. So LCM of 4, 26 is 52. Now there are a couple of properties related to HCF and LCM, which are product of two numbers is equal to HCF of them into LCM of them. For example, HCF of 4, 26 is equal to 2 and LCM of 4 and 26 is equal to 52. Now 26 into 4 is equal to 104 and 52 into 2 is also 104. So this case is validated. And there is one more thing related to this, which is LCM is a multiple of HCF. So yes, it is evident that 52 is a multiple of 2. So this is also validated. Now let us see how to find the HCF and the LCM. But before that, let us see HCF and LCM of fractions. So let us say the two fractions are A by B and C by D. So here we will consider A, comma B, comma C, comma D belong to the set of integers and B, D not equal to 0. And if this is validated, then these will be the fractions. Now, HCF of A by B, C by D is equal to HCF of numerators A and C divided by LCM of denominators B and D. For example, 2 by 3 and 5 by 12. So HCF will be HCF of 2 and 5, which is 1, and LCM of 3 and 12, which is 12. So is equal to 1 by 12. And for finding the LCM, what we simply do is we take the LCM of numerators and divide it by the HCF of denominators. So here LCM is equal to 10 by 312. So LCM is 3. Sorry, HCF of 3 and 12 is 3. So this is 10 by 3. So that is pretty much it for the HCF and LCM of fractions. And now we will see how to find out the HCF and LCM. So see, one of the methods of finding the LCM is by long division method, wherein let us say we have to find the LCM of 12, 18, and 27. So 12, 18, 27. What we will initially do is divide it by 3. So division by 3 gives 4, 6, and 9. Now, can we divide it further so that each of the number gets reduced? No. So the answer to this will be 3 into 4 into 6 into 9. Okay. So this will be the LCM. And for finding the HCF, the HCF will be 3. So for HCF, you multiply all the divisors that are on this column, you get the HCF. And if you multiply it by all these values, you get the LCM. But there is one more way. If you are given the value in the form of exponents, let us say 2 to the power 3 into 5 to the power 7 and 2 to the power 3 into 3 square into 5 cube. If you are given the numbers in this form, then HCF will be common factors and the lower power of them. So 2 to the power 3 into 5 to the power 7, 5 to the power 3. Which one is lower? 5 cube. So this will be 5 to the power 3. And for LCM, you will take the highest power of each of the prime components, which is 2 to the power 3 into 3 to the power 2 into 5 to the power 7. So this will be the LCM and this will be the HCF. So this is pretty much it about how to find the LCM and HCF. So now let us look at some axioms that are valid for the LCM and HCF. So any number which when divided by P, Q, or R, leaving the same remainder, S in each case will be of the form K into LCM of P, Q, R plus S. For example, we have a question. A number when divided by 3, 5, and 7 leaves the remainder 2 in each case. So you have to find the fourth smallest such number. So the number will be of the form k into LCM of 357. It will be multiplication only because they are co-prime numbers. So 3 5s are 15, 15 7s are 105 plus 2. Okay. Now the fourth smallest number can be found out as k is equal to 3 because k can be any whole number. So k is equal to 3 gives 1053s are 315 plus 2 is equal to 317 will be our answer. So such questions have also been asked in actual CAT a few times. So you can use this axiom for solving such questions. The second axiom is any number which when divided by p, q or r leaving the remainders stu wherein p minus s is q minus t equals r minus u, then the number will be of the form this, where k can be any whole number. Okay. So this is again a formula that can be remembered. So for example, let us say the numbers are 11, 21 and 33, and division gives a remainder of 9, 19 and 31. Okay, and you have to find the number. So the number will be k into LCM of 11, 21, 33 minus this v. Now what is v? 11 minus 9, 2. So this will be the format of the number, wherein you can put the values of k and get the answer. Now generally k can be any whole number, but putting -2 gives a negative value. So here k needs to be a natural number for the number to be positive. Okay, so if you are asked positive, so k will be a natural number. So there are a couple of more axioms that are related to HCF. So the largest number which with the numbers p, q or r are divided, giving the remainder s, t and u respectively will be HCF of this. So let us say the numbers are 25, 30 and 35, which when divided by s give a remainder 5, 10, 15. So the HCF will be 25 minus 5, 20, 30 minus 10, 20, and 35 minus 15, 20. So HCF of all this is 20. So 20 is the required number. And last but not the least, the axiom that the largest number with which if we divide numbers p, q and r, the remainders are same. Okay. So p, q and r divided by a certain number leaves the same remainder. So it will be HCF of p minus q, p minus r and so on. Okay. So these three quantities are equal in that particular case.